Limits at infinity, at least dealing with them algebraically, are just a special case of the other types of limits that we've already looked at. We've looked at dealing with limits at infinity graphically, in which case we go to the far left or the far right, depending whether it's negative infinity or positive infinity, and we evaluate what the graph is doing at those places. To deal with it algebraically, if we had a limit as x approaches 2, we can substitute a 2 in to the function and work out the math. Infinity, we cannot technically directly substitute in because infinity isn't actually a number. And along with this, we can only actually evaluate limits infinity of rational functions. If these are not rational, then we can't evaluate the limits at infinity. In order to manipulate the functions to make it possible to evaluate a limit at infinity, we have two things we have to do. One is divide every term by the highest power of x, and two, this is in quotes because again, we can't substitute infinity in, but we will substitute infinity into the new expression and then evaluate it. So A here, limit x approaches infinity of 6x minus 5 over 2x plus 3. The highest power of x is x. So we will take this and we will divide every term by x. Now it's going to look a little complex and convoluted, and I'm purposely doing the dividing as slants so we have a visual. But we are literally dividing every term by x, the highest power in this case. Now, what I didn't put in the steps is we actually have to do one step in here before substituting infinity. We actually need to take this and simplify it out. So each term, look at it, 6x over x, well, the x's can cancel, and that is 6. Minus 5 over x, we actually have no x's to cancel, so it stays as 5 over x. 2x over x, again, we can cancel the x's, we get 2. Plus, and again, 3 over x, we actually cannot do anything with. At this point, we can now actually substitute in the infinity in for x, so 6 minus 5 over infinity over 2 plus 3 over infinity. And now we need to actually do some math with infinity. What we have here is we have 5 over infinity. And this is essentially 5 over an extremely large number. The largest number in existence, and then some. And as we take any number, 5, 3, 1, and divide it by an extremely large number, that essentially becomes 0. It limits out to 0. The bigger that denominator gets, the smaller that answer gets, and the closer to 0 it gets. And for us, since we are approaching infinity, as a limit does, we are going to approach 0 with these 5 over infinity and 3 over infinity. And for all intents and purposes, because this is a limit, we can call those 0. On the top, we get 6. On the bottom, we get 2. And when we divide those out, we get 3. B will follow the same process. Looking at the exponents, the biggest exponent we have is x squared. So we will take every term and divide it by x squared. And as I said, this does get large, it does get convoluted. but there is no way of avoiding the process here. Going through, we have 2x squared over x squared. The x squareds completely cancel. That is a 2. 5x over x squared. One of the x's can cancel, and we will have 5 over x. Not 5x. We have 2 x's in the bottom, 1 on the top. More on the bottom than on the top. Plus, and 2 over x squared here. We have no x's to cancel, so it stays as is. On the bottom, x squared over x squared, those cancel out, but they cancel out to 1. It is x squared divided by x squared. Something divided by itself is 1. We need that there. Minus, with 9x over x squared, we have 1x that can cancel. That would be 9 over x. This is the place we can shortcut a little bit. This would be the step where we substitute in infinity into the x's. We don't actually need to do that because we know what those will become. 2 is 2 plus 5 over x becomes 5 over infinity. Anything over infinity is 0. Plus we have 2 over x squared, so 2 over infinity squared. And infinity squared is just a larger infinity. So in reality, that is also 2 over infinity, which is 0. The bottom, we have 1 minus, and 9 over x is also, after plugging in infinity, going to turn out to 0. Working that out, the top is 2, the bottom is 1, and 2 divided by 1 is 2. Continuing on C, now it's not x approaches infinity, it's b approaches infinity. Doesn't change anything. We'll still divide by the highest power. That happens to be b cubed this time. So the top, 3b squared over b cubed. Bottom, b cubed over b cubed minus 4b over b cubed. Start canceling. On the top, we'll have 2 b's that can cancel, but still not totally. That will end up being 3 over b. The bottom, b cubed over b cubed, they completely cancel again to 1. And 4b over b cubed, one of those b's will cancel. That would be 4 over b squared. Substitute in the infinity now. On the top, 3 over b, 3 over infinity, 0. On the bottom, 1 minus 4 over b squared is 4 over infinity squared, so 4 over a bigger infinity, also 0. Working that out, top is 0, bottom is 1, and 0 divided by 1 is 0. D, we're back to x approaching infinity. Again, the variable doesn't matter. We'll divide by the highest power of x, which happens to be x cubed. So 4x cubed over x cubed minus 2x squared over x cubed over 6 over x cubed minus 5x over x cubed. Start canceling. 4x cubed over x cubed goes to 4 minus 2x squared over x cubed. 2 of those x's cancel. goes to 2 over x. Six over x cubed, nothing cancels, so it stays as is. And 5x over x cubed, one of the x's cancel. It is 5 over x squared. Substituting the infinity, we'll have 4 minus 2 over the infinity is 0. 6 over the infinity cubed is 6 over an excessively large infinity. So again, still 0. 5 over the infinity squared, also 0. Simplifies out to 4 over 0. And if we tried to type this into a calculator, we would get an error message because this is impossible. And as we know from talking about functions, anytime we had a divide by 0, this was technically a vertical asymptote of the graph. But since we're talking about the function and not the graph, vertical asymptotes are infinities. So as you can see, these limits can work out to anything from a real number to 0 to infinity, and actually anywhere in between depending on the setup of the question.